Okay, cryptography. So as we deal with integers, first of all, we have to know about set of integers and what the operations available. There's binary operations, integer division, divisibility, and linear Diophantine equations. আমরা দেখি যে এই বিষয়গুলো সেট অফ ইন্টিজার্স বলতে বুঝি আমরা যে জেড দিয়ে আমরা ডিনোট করি এবং এটা মাইনাস ইনফিনিটি থেকে প্লাস ইনফিনিটি পর্যন্ত সেটা নেগেটিভ নাম্বারস পজিটিভ নাম্বারস ইনক্লুডিং জিরো all the numbers all the numbers with no fraction. তো সেটাই হচ্ছে আমাদের সেট অফ ইন্টিজার্স from negative infinity to positive infinity. এবং সেট থিওরির প্রথম জেড নোটেশনটা ইউজ করা হয়েছিল, সুতরাং এই জেডটাই হচ্ছে আমরা এখন ইউজ করি জেড সেট অফ ইন্টিজার্স। In cryptography, we are interested in the binary operations. Binary means okay, two values are there, and interested in three binary operations and applied to the set of integers only. And binary operation takes two inputs and creates one output. So the three binary operations. তার একটা হতে পারে যে ওকে এডিশনের সাথে হচ্ছে সাবট্রাকশন, আরেকটা হচ্ছে যে মাল্টিপ্লিকেশন। ওকে, জেড থেকে যদি আমরা কোনো একটা নাম্বার পিক করি এখান থেকে a and picking another number b, and we can operate on a and b with operators addition, subtraction, or multiplication, and you get the result c, and which is also in the set of z. তার মানে আমি যখন ইন্টিজার অ্যারিথমেটিক ইন্টিজার অপারেশন করছি, the result is also in the set z. Suppose 5 plus 9 is 14, and if it's minus 5 plus 9, so we are actually dealing with addition. And again, subtract 5 minus 9, or this minus 5 minus 9, or minus 5 minus 9. Any kind of operation, sorry, is possible. The number can be positive or number can be negative. Okay, another thing is division. And an integer arithmetic, if we divide a by n, we can get q and r. That means the relationship is a is equal to q n plus r, meaning if you divide a by n, then the quotient is q. So I can write a is equal to q times n plus the remainder. Normal arithmetic, আমরা যেটা শিখে আসছি, quotient, and this is my dividend, this divisor, this is the remainder. So I can write z, any integer. I'm picking any integer value from z, and I'm dividing this value a by n, and you remember that n is a positive quantity. N is a positive quantity, and you're getting r, and this r must be a non-negative integer. Non-negative. What is non-negative? Shapnil, non-negative বলতে কি বোঝায়?
Positive থেকে minus plus infinity, sir.
Yes, again.
Sir, 0 থেকে plus infinity.
Yeah, 0 is included. There is non-negative. Yeah, positive plus 0. Yeah, that is the non-negative. So আমাদের যে অ্যারিথমেটিকটা আমরা এখানে করব ক্রিপ্টোগ্রাফিক ম্যাথে, সেখানে হচ্ছে যে আমাদের রিমাইন্ডারটা অবশ্যই হতে হবে নন নেগেটিভ, এবং সেটা আমরা দেখবো যে যখন আমরা মডুলার অ্যারিথমেটিক করবো, নন নেগেটিভ হতে হবে একটা কন্ডিশন, আরেকটা হচ্ছে যে স্মলেস্ট. So again, when you divide, the quotient is also in the set Z. Like minus 255. Minus 255, I am dividing by 11. So that is minus 23 into 11 plus minus 2. But I cannot use this minus 2, remainder minus 2. Instead, I can use 24 here, not 23, 24 here, so that my remainder becomes a positive quantity or non-negative quantity. Clear? Is it clear? আমি এখানে যদি -23 ইউজ করতাম তাহলে আমার রিমাইন্ডারটা ছিল -2. সো -2 আমরা ইউজ করব না, আমি ইউজ করব হচ্ছে আমি পজিটিভ নন নেগেটিভ রিমাইন্ডার আমার দরকার, সুতরাং I shall take -20. Okay, graph of divisional algorithm. So I have a 0 to any value is a positive a, so 0 to any value, and if I divide it by n, so this q times n is here and a is here, so remainder is r, is the positive quantity r. So qn plus r is equal to a. Or when a is negative, negative, okay, in case of negative, so my q is negative, sorry, a is negative, so I can go minus, I can go, if I divide by n, positive n, so there is minus and -1, minus n. If I use -2, minus twice n. If I use there is qn, q times n, q is actually, you go here negative. If n is positive, q will be negative. So qn, and that is my q minus 1n. So I'm just adding r so that I can reach a. আমি qn না নিয়ে আমি কিন্তু q minus 1n নিচ্ছি, যাতে কিনা rটাকে আমি যদি এখানে নিতাম আমরা, so r will be negative. If I take this point, r will be positive. A simple thing actually. Okay, divisibility. If a is not 0 and let r equal to 0 in the division relation, we get a is equal to qn. So if the remainder is 0, then definitely a is equal to qn, and in that case we call ঝামেলা আছে মনে হচ্ছে যে n divides a. That is not like that, a divides n না. So it will be, I think, n divides a. তবে n হচ্ছে a কে ডিভাইড করে if the remainder is 0. So we can write, and if remainder is not 0, so n not divide a. পরবর্তীতে ঠিক করা আছে আমার নোটেশনটা। জি,
আজকে কয়টায় লেডিস ক্লাব তাই?
Okay, if 4 was 32, if I can write 32 is equal to 8 times 4. 4 is my n here, so I can write 4 divides 32. তার মানে এই নোটেশনটা কিন্তু ভুল আছে না? You can check and you can just 4 divides 32. And if 8 doesn't divide 42, so I can write 8 doesn't divide 42. So it's a simple thing. Sum of property 1, if A divides 1, if A or any value n, you can write n divides 1, then A or n will be plus minus 1. And if A divides B and B divides A, so A will be positive, negative B. Definitely. And if A divides B and B divides C, so definitely A divides C. And 4, if A divides B and A divides C, then A divides NB plus NC. A যদি B কে ভাগ করে, some MB times A is equal to MB, and A divides C, so C is equal to N of N times of okay, A divides C, when A is equal to C is equal to NA. যদি C কে ডিভাইড করে, so integer times C কেও ডিভাইড করবে। যদি B কে ডিভাইড করে, integer times B কে ডিভাইড করবে, এবং তাহলে সামেশন কে ডিভাইড করবে। That's the thing. আমার কথা কি শোনা যাচ্ছে?
স্যার শোনা যাচ্ছে স্যার।
Okay. So in an example here, 13 divides 78, 7 divides 98, minus 6 divides 24, like that. 11 divides minus 33. 3 divides 15 and 3 divides 9, meaning 3 divides 15 into 2 and 9 into 4. Okay, see the fact 1 and 2. The integer 1 has only one divisor, and it is itself. And fact 2 is any positive integer has at least 2 divisors. At least. So any positive integer has at least, because it divides itself or 1. Know that. This prime number. Consider prime number. It divides itself and it is divisible by 1. So, which is important in cryptography, that is GCD operation. So we have common factors of 140 and we have common factors of 12 factors. So 140 common factors is 1, 2, 4 and others, and divisor of 12 is 1, 2, 4 and others. So these are the common factors. These are the common factors. So from these common factors, the greatest common factor or common divisor, that is 4. So the greatest common divisor, we also call it GCD, of two positive integers is the largest integer that can divide both integers. Okay, আমাদের এই যে জিসিডি অ্যালগরিদমটা, এটা আসলে আমরা যেটা ম্যাথ করি সেটা আসলে it was proposed by Euclid. Know that Euclid also contributed in geometry. So what is the fact that is used in a Euclidean algorithm? GCD A0. If we are calculating the GCD of two numbers, and if one number is 0, then GCD becomes A. And this is important property. This is important property that GCD of AB, we can write it in terms of GCD of this B and R. অথবা বলতে পারি R means হচ্ছে যে modulus of A divided B. That's interesting property. তার মানে যদি আমি জিসিডি বের করতে চাই দুটো নাম্বারের, সেটাকে আমরা লিখতে পারি যে নাম্বারটা যে another number, let's say the B is smaller number. In that case, we can write it GCD B is the smaller number, so we can go for a more smaller form. It becomes B, and this R actually A mod B, A mod B. Remainder. If I divide A by B, and if the remainder is R, so I can write GCD AB is equal to GCD of BR. তাহলে যদি ইউক্লিড অ্যালগরিদম দেখি আমরা, যদি আমরা সবাই জানি, স্টিল লেটস চেক দ্য অ্যালগরিদম। আমাদের দুটো ভেরিয়েবল নিব আমরা, R1 and R2. Initially we are assigning R1 is equal to A and R2. And first we calculate the remainder of, তার মানে হচ্ছে যে I am dividing R1 by R2, and we get the remainder R. The next step, R1 becomes B, the second number, and R2 becomes the remainder. And again, if I calculate the modulus, I am getting R again. Now I am updating R1 with R2, previous R2, and R2 with the remainder. So when you stop, when I get R2 is equal to 0, then my GCD is equal to R1, because from the definition, the two numbers R1 and R0, the GCD is R1. ঠিক আছে এটা? It's okay. Swapnil?
জি স্যার, বুঝতে পেরেছি।
তাহলে এটাকে আমরা জাস্ট এই অ্যালগরিদমটাকে আমরা জাস্ট we can write it in a functional form. Okay, from this, if the GCD of A and B is equal to 1, then we can say that A and B are relatively prime. Relatively prime means they don't have any common divisor other than 1. The prime number not necessarily prime numbers. যেমন আমি বলতে পারি 3 and 5. What's the GCD of 3 and 5? কত হবে? GCD of 3 and 5 কত হবে?
1 স্যার।
1 sir.
1 হবে. So in that case, we call these numbers they are relatively prime to each other. But 3 and 5 both are prime numbers. But if I ask you, what's the GCD of 9 and 5?
1 স্যার।
5 and 9.
1.
is also 1. But এখানে সেই prime concept নিয়ে আসছি আমরা বলছি okay, still 5 is a prime number, 9 is not, but 5 and 9 are relatively prime to each other. ঠিক আছে? So when GCD AB is the 1, we say that A and B are relatively prime. Relatively prime there. Okay, this is an example. অনেক সময় আমরা বলি যে okay, যদি আমাদের দুটো নাম্বার দিয়ে দেই, okay, calculate the GCD using Euclidean algorithm. If I ask you Euclidean algorithm, you will just setting up a table, this R1, R2, Q, and R for two variables, and you will need this remainder R also, and also quotient. So the first step, there is my, here it is R1 is 2470. Sometimes you ask. So first of all, you put these values. Then you divide R1 by R2 and write the quotient and write the remainder. Then you replace this R1 with this R2, and you replace R2 with this R. And again, go for the next operation. You divide 760 by 980. The quotient is 1, and remainder is 780. So go like that, and when you get the value 0, R2 is equal to 0, so you get the GCD is equal to 20. Okay, similarly, find the greatest common divisor of 25 and 65. যদি আমরা উল্টোটা নেই, অর্থাৎ বড়টা আগে বা ছোটটা পরে, এটা নিলে কিন্তু it will work. Not necessarily যে আমাকে এটা সবসময় বড় রাখতে হবে এবং বিটাকে ছোট রাখতে হবে, it will also work. R1 is 25, R2 is 60, so quotient is 0, and remainder is 25, so 60. Next step দেখা যাচ্ছে যে R1 will become a bigger number. Okay, symbol এটা আমরা জানি করে এসেছি, এটা নিয়ে আবার আমরা আলোচনা করছি because এই বিষয়টা আমাদের লাগবে. What is important? সেটা হচ্ছে extended Euclidean algorithm. That is important. Extended Euclidean algorithm তারা বলছে যে ওকে, আমরা যদি দুটো নাম্বারের জিসিডি থেকে if you can express in terms of linear combination SA plus TB, S এবং T addition of and coefficients multiplication S and T, SA plus TB, এই ফর্মুলা লিখতে পারি. If I can write GCD of two numbers, SA and TB, from that we can extended algorithm can calculate the GCD of AB, and at the same time we can calculate the value of S and T. কারণ এই ভ্যালু দুটো আসলে আমাদের লাগবে, কেন লাগবে আমরা পরে আসি. আমাদের A এবং B জানা আছে, এবং এই জিসিডি এই যে ভ্যালুটা, if I can write it S and TB, আমরা দেখবো যে in that case this S and this T will be used in other purposes. Okay, let's go for that. What is the extended Euclidean algorithm? So again, the steps are, I have R1 I have R1 is equal to A, I have R2 is equal to B as before. R1 A, R2 B, and if I divide R1 by R2, the remainder is R. Okay. There is the Euclidean process. Then I am updating R1 with B and R2 with R. I am dividing, I'm getting remainder R. I'm updating this. And when I get 0, then R1 is the remainder, the GCD. Okay, what I do along with the operations. S1 is equal to 1 and S2 is equal to 0. So this initialization I must do. I need S and T, two values. Just instead of S, I'm writing S1, S2, I'm writing T1, T2, just like R1, R2, similar. So I have to set S1 is equal to 1, and S2 is equal to 0, and T1 is equal to 0, T2 is equal to 1. So this is important initialization step. Our first part হচ্ছে Euclidean algorithm মধ্যে চলবে alongside যেহেতু আমি S এবং T বের করতে যাচ্ছি I want to find out the values of T, S and T. So I have to assign S1 is equal to 1, S2 is equal to 0, T1 is equal to 0, and T2 is equal to 1. Then same thing, I shall do the same operations along with the Euclid. So I just here I can take this remainder S, and I shall update. I shall update this S2 with S1 and S with S2. And similar operation is here. T1 0, T2 1, then this the remainder is T. And I can update, I shall update this T1 and this T.
স্যার এসটা কি
Okay.
স্যার S1 হচ্ছে 1, S2 0 আর এসটা কি বুঝি নাই স্যার।
Okay, let's check. Let's check the same thing actually. Yes, the remainder, yeah, same thing, the remainder. Okay, let's check. So this is the initialization when I go for algorithm or writing some function. R1 is equal to A, R2 is equal to B definitely, and S1 is equal to 1, S2 is equal to 0, T1 is equal to 0, and T2 is equal to 1. And I am iterating when the condition is true, is R2 greater than 0. When R2 is equal to 0, we'll stop. So R2 greater than 0. So first thing is you are calculating the quotient Q, but quotient Q and remainder R. These two things. Quotient Q, remainder R. So R is the remainder, and I am updating R1 with R2 and R2 with R. First step. Second step, I am not dividing anything. I have already got Q. So using Q, I am getting this remainder. Yes. And as I have got Q, again, using Q, I am okay, getting the remainder T, and from this I'm updating T1 and T2. তাহলে কি বুঝতে পারছো স্বপ্নিল?
Yes sir.
Is it clear? Rest of you? সবাই কি বুঝতে পেরেছি আমরা?
Sir, I have a query, sir.
Yes.
Sir, if we initialize the S1, S2, T1, T2 always with a constant, sir, so their result will be the same in each iteration, sir.
Result will be same, not necessarily.
Means if we go to the previous slide, sir, kindly.
Result will be same. Let's check. Yeah.
In the previous slide, sir, if,
Yes.
sir, here. So every time we are initializing S1 with 1 and S2 with 0, equally T1 equals to 0, T2, then this iteration will every time give the same result, sir.
Actually, এখানে যেটা হচ্ছে যে এখানে কিছু হিডেন একটা তথ্য এখানে আছে যেটা বলা হয়নি, সেটা হলো this s, how can I, এইভাবে না, this r is the remainder. It's okay. S is also the remainder, but not dividing S1 by S2. I am just using here the quotient Q. Q is not written here. We must have to use Q as the quotient. Then the remainder is S.
Then it's okay, sir. It's okay.
Yeah. Okay, let's check here. Okay, Q again. We have the values. Q, R1, R2, R, S1 is to S, T1, T2, T. So if I ask you in the examples, so just you write this variables first. Q, R1, R2, R, S1 is to S, T1, T2, T. So first thing, this 161 and 28. Sorry, find the GCD and also the values of S and T. Okay, so first thing is I am writing this. Only I have these values 161 and 28. So 161, 20. First, I am dividing R1 by R2. Then I am getting quotient 5 and remainder is 21. এরপর না পেয়ে গেলাম আমি। Then I have already assigned S1 equal to 1, S2 0. Then what will the value of S? And S is equal to Q times S1 minus S2. So Q মানে 5 times okay, dividing S. Okay, Q times S2. Q times S2. I am dividing S1 by S2, and the remainder is 5. So that is my quotient is 5. That is my remainder. That means I have to write S in terms of S1 minus Q into S2. তার মানে আমাকে S1 ছিল কত আমাদের? S1 is equal to 1. Q1 হচ্ছে 5. Q5 and S2 হচ্ছে আমাদের 0. So you're getting 1. That's the one. Similarly, okay, similarly, as T1 and T2 is already assigned, I want to get the value of T. So what will be the value of T? T is here T1 minus Q into T2. তার মানে T1 হচ্ছে কত আমাদের? T1 হচ্ছে 0 minus Q হচ্ছে 5 into T2. T2 হচ্ছে আমাদের 1. that means -5. এই স্টেপগুলো আমার হয়ে গেল যখন, so you update for the next step. So this R2 will be R1 and the remainder will be sorry. Then we are updating this R2 with R1 and R2 with R. So with S1 with S2 and S2 with S, and then T1 with T2 and T2 with T. So now you have to calculate again what is quotient, what is remainder, what is S, and what is T. Clear?
স্যার এখানে S1 S2 যেমন আপনি ধরলেন 1 আর 0, T1 T2 0 and 1, এটা কি সব সময় এরকমই হবে স্যার?
ইনিশিয়ালাইজেশনে তাই, প্রথমে তাই 1001
1001 স্যার।
0, yes. কেন হবে 1001? কেন হবে? Any idea? Yes, and T. S1, S2, 1 and 0, and this is 0 and 1. Okay, we shall check why. Because GCD of AB, we are writing in terms of S into A plus T into B. Right? S into A, T into B. So why it is, okay, we have to check why it's 1 and 0. But the initialization is fixed. 1001 is fixed. Okay, check why they have chosen this. ওকে, এটাকে ঠিক আছে। তাহলে আমি এখানে যখন আর পাচ্ছি আর এর 0 আর 2 এর 0 পাচ্ছি, so my GCD is 7 and it will work also. You see that GCD is equal to 7 and this is my S and this is my T. S1 is equal to S and T1 is equal to T. ঠিক আছে? Any question?
Sir, actually, where
Okay.
is it applied, sir? This,
Yes.
Where do we apply this, sir?
সেটা আমি আসছি। We are coming to that point. So again, if the B0, so B0 means the first step. So this R1 is the GCD. So then S1 is to 1 and T1. So actually now you see that now it's evident that as S into A plus T into B is the GCD of AB. So if one value is 0, value is 0, so only s into a. So definitely, and this value will be a, then definitely this s will be 1 into a. So this is from the trivial condition. Second, again, there is it may happen that 0 and okay, let's b 0 and b. That case is into a. It will be b. It will be b. এখানে কি হবে যদি 0 হয় b হয় তাহলে এই কেসে তো জাস্ট 1 দেখে এমনি বোঝা যাচ্ছে দেন ফর নেক্সট কেস নেক্সট কেস কি হবে you check this. Okay, there is a okay, this is the same case. A is 0 and b is 45. Then what will happen? You see that it comes out t is equal to 1 and s equal to 0. So why we are assigning a 0 and s 0 1 and 1 0 from this evident. So our base case গুলো কিন্তু যদি আমি 1001 না ধরি তাহলে কিন্তু স্যাটিসফাই করবে না ঠিক আছে এই কোশ্চেনের গার্জিয়ান ছিল হুমায়ুন নাকি
Right, sir.
So you see that if I do not write this 1001 the base case will not satisfy. Now এখন যদি t এর ভ্যালু 1 হবে আর t এর ভ্যালু 1 মিনিং হচ্ছে যে s এর ভ্যালু 0 s এর ভ্যালু 0. Okay, if I ask you to find out the values, let's try. Exercise day to try to find out GCD of let's 135 and 9. Using this and also find out S and T. Just try out yourself. And we're taking a break, huh? ঠিক আছে let's take a break for a few minutes and try out GCD 9135 using this extended Euclidean algorithm. ঠিক আছে স্বপ্নিল
স্যার আছি স্যার
okay let's try out huh
yes sir
okay
স্যার এটা অ্যান্সার হচ্ছে জিসিডি 9 এর ভ্যালু 0 আর টির ভ্যালু 1 স্যার।
ওকে, আমি একটু ব্রেক দিচ্ছি, আরো 5 মিনিটস, বাকিরাও করুক। হ্যাঁ।